In this video, I'm going to show you where the kinematic equations actually came from. So we'll be deriving the kinematics. Just so you recall, these are our four kinematic functions. And we're going to start by getting number one. Number one is really easy. You actually just start with your equation for acceleration. And you solve for VF. So let's go ahead and do that. Just going to switch this around. I'll add this to both sides. And here is equation number one. Now we're going to move on to equation number four, because we need equation number four for the other ones. So for equation number four, we need to remember two things. One is that if you have the average velocity, then another way to get average velocity is initial velocity plus final velocity divided by 2. So that's just like if you have velocity one place and you have velocity at another place and you divide by 2, then you get the average. So you should all know averages. One item plus another item divided by how many items there are gets you the average of the items. Another thing you need to remember for this fourth equation we're about to derive is that we need to remember our ninth grade equation. So distance equals speed times time. But we're going to change it around a little bit. We're going to change it to displacement equals average speed times time. So we will end up with, so remember, displacement is final position minus initial position. And now I'm just writing in this guy right here, average speed, times time. If you rearrange this slightly, so I'm going to take out this 2, make it a 1/2 on the outside of the parentheses, and I'm going to add initial position to both sides. And now we have equation number 4. Okay, so now we are going to get equation number 2. So this one is a little bit trickier. What we're going to do is we're going to put equation 1 and equation 4 together. So basically what we're going to do is we're going to take this VF and plug it in for this VF here. Again, what we're going to do is we're going to plug in this stuff into here in equation number 4. So once you do that, separate that out. You get that. So now we can rearrange this and you'll see that it will look like equation number 2. So I'm just distributing that 1/2. And I'm also distributing the t. Now these are like terms, so let's put them together. And now we have equation number 2. Then we need to derive equation number 3, which is probably the trickiest. Now the first thing we want to do to get equation number 3 is we want to solve equation number 1 for t. So I'm actually going to start at this step. So we have AT equals VF minus VI. If we solve for t, we get VF minus VI over A. Then we want to plug this into equation number 4. So remember, equation number 4 is this guy here. So we want to plug this stuff in right here. Once we do that, you will end up with that. And I'm going to do a couple things here. One, I'm going to take out this A and put it with the 2 here. I'm also going to subtract xi from both sides. All right, now, if you rearrange this in your mind a little bit, and I'll actually write it down for you. Let me use a different color. You'll actually see that this is a difference of 2 squares. I believe it's called. So when you FOIL it out, you can just drop that center term because it'll cancel out. So what you will end up with is that. Next thing I'm going to do is multiply both sides by 2a. Then I will add vi squared to both sides. And there we have our equation number 3. So I hope you understand a little bit better where these equations actually came from.